What's up, guys? This is Mr. Burns. This is a tutorial video walkthrough for your 1.2.3 simulated electrical circuit submission form. We're going to go to our PLTW curriculum and scroll down to the correct activity. On your black navigation bar on the left, we're in lesson 1.2, 1.2.3, and it's this alternate activity over here on the left. It looks like this. You've got distance learning support logo at the top. You know you're in the right spot. Okay. The first thing that we want to do is we want to join our Tinkercad classroom and perhaps create an account if we don't have one already. When you click on the link that I provided to you, it brings you right to our class. If you're prompted to log in, you're going to use your school Google. If it prompts us to use this code, the code is right here. So we are going to join with Google. And it says, what account do you want to use? I'm going to use my advisory account. You're going to use your school account. We're going to accept the conditions and hit continue. And you're here. And it's saying, hey, cool, welcome to Tinkercad. If you've already got a Tinkercad account, you can just use your Google account, but you should end up somewhere like this. Okay. Once we've got in, we're going to start building our first simulated circuit. We're going to follow steps 6 through 31. This is not going to be the entire lesson in PLTW, but we're going to start on step 6 and make our way down to step 31. And you're going to follow along with this tutorial video if you need to. We're going to insert our work in the table here, and we're going to see what it says at step 6. While we're scrolling, all this stuff is good to read, good to review. These are the vocabulary words that I think that you know. So if you haven't yet reviewed this stuff from physics, definitely check this out. All right. We did the introduction to electricity resources for homework, and we did the practice calculations. There is some schematic review here. You can refer to this table back to see, what does the switch look like? Oh, it looks like this thing right here. We'll talk about it when we get there. All right, review Ohm's law, B equals IR. Great. We're down here at step 6. We've created our account. We're ready to start cooking. We're going to not do 3D designs. We're going to click on circuits and create a new circuit. It looks like this. Circuits, create a new circuit. While that's loading, it says you can go to this Tinkercad Circuit Tips. This is a resource that provides way more information on how to use and operate Tinkercad. There's all sorts of screenshots and helpful videos in here if you need it. The curriculum provides way more support than you're probably going to need. You guys are all pretty good computer users, and you can click and figure it out yourselves pretty quickly. All right. The first thing we need to do is rename our circuit model to POE. No, we're not going to use that. I'll tell you how to do it. We're going to rename Glorious Magello, or whatever yours is. You're going to call this 1.2.3 Sim Circuit, and then you're going to use your initials. I'm MDB. Okay? You can get out of this little window here. That's cool. Before you change this to all components, you might want to grab this battery right now and throw it onto your workspace. They like to orient it maybe this way or whatever way works for you. And then you can make sure that you have all the components selected. There's a whole bunch of them to choose from. All right. We are now at step 11, where we need to add a multimeter. Okay. You can just type in multimeter in this search box, and you can find that multimeter right here, and click on it right here to bring it into your workspace. And the way that we connect the multimeter is that you can just click and drag from one terminal of the battery, one terminal to the multimeter, and connect those two. Okay, if you don't like what you're seeing, you can always delete your connections and redo them. One thing that I learned is that if you click from a terminal and in a different space, you can kind of make a bendy wire like this. All right, so you can design your wires to your heart's content. All right, once you've got your multimeter selected, all right, you can choose between amps and voltage or resistance. We're going to use voltage, and we're going to click Start Simulation, and we can see, uh-oh, I've got -9 volts. Okay, if we stop the simulation and we rearrange the way that these wires are connected, All right, I'll delete that one, and we'll connect this one to the positive terminal. Let's move that over, and then we'll connect the negative to the negative terminal. When we click Start Simulation, you'll see that we got a positive 9 volts. All right, we are currently at step 11. Okay, it says when you start the simulation again, what do you notice? You can click on Check Results. All right, if you've got your wires crossed, you're going to get a negative value on your voltmeter. All right, so if you connect the positive and terminals to the positive and the negative to the negative, you'll have a positive result for your reading there. We're moving on to step 12, where it says interpret the schematic in figure 4 and model this in Tinkercad. All right, I see that I've got this schematic symbol here. I've got another one here. I've got something that looks like a light bulb here, and then we've got a capital V up top. If you don't know what those are, you can scroll to the top of this lesson where it's got a key, electrical circuit components for schematics, your battery source, right? That's the 9-volt battery right here. You could also use a variable power supply. The wires are what connect your different components. We've got an open switch. I'll teach you how to use this. We've got a light bulb. It'll look like that. Okay, and we just use the voltmeter, and that's what this big capital V inside the circle is for. So let's get back down to step 12, where it says interpret the schematic and build it on Tinkercad. All right, you can delete these components. You can start from scratch. All right, you can just delete. You could have just separated them if you wanted to. I'm going to type in power to find my 9-volt battery. I'm going to use this button to rotate it like that. All right, I'm going to find a switch. All right, we're using this slide switch right here. Okay, I need a light bulb, so I'll type in light, and I got the light bulb right here. All right, and I'm going to rotate that also kind of like this. And then we needed that multimeter for measuring voltage. Okay, and I might actually rotate that one as well, but you can do it whatever way you like. Okay, so how do we connect these different components? We want the battery to go up to the switch to go to the light to return to the negative end of the battery, and then this voltmeter gets connected in parallel to this, okay? And so we're simply going to drag our leads to where they need to go. If you connect this wire here, all right, and then you connect to your light bulb, all right, you're going to run into a little bit of a problem, okay? Oops, let's connect that. Just to show you, start simulation, all right, I can't get this light to turn on, all right, and the reason why is because you're actually going to connect your positive terminal to this middle common area here, and then it's going to come out of this third part of the switch there, okay? So make sure that you're connecting your positive terminal to the middle of your switch, and when you click Start Simulation, you can turn this light switch on and off, okay? But we're not done yet, because if you look at your schematic, you got to connect the voltmeter in parallel. All right, so we'll come back over here. We're going to add from my negative side. Let me hit escape here. From my negative side, I want to connect to the negative terminal, and from my positive side, I want to connect to the positive end of the circuit here. We can start our simulation, and then when we register 0 volts when the switch is not turned on, or the switch is not closed, or rather when the switch is open. When we close the circuit and the light bulb turns on, we get a reading of 8.73 volts. All right, and you're prompted with 1 to check your work to make sure that you've connected everything correctly, and there's an example of it right here in the curriculum. All right, and it says what was the voltage when the light bulb was not on, and what was the voltage when the light was on. All right, we got 8.73, and so did they. And we're going to put a screenshot of this circuit into our turn-in. All right, if you're on a Chromebook, I believe you can, there's some hotkeys that you can use. I'm on a Mac, so I'm going to hit Command-Shift-4. All right, we're going to grab a photo of this circuit, go over to our turn-in, and we're going to insert that image into our submission form. My screenshot is going to pop up in just a second. I think this is the one. Okay, And then there's a reflection question. After step 14, was the voltage across the battery what you expected? What could you account for any difference observed? You're going to type in your answers here. And if you could use a different color font, I like it when students use this funky purple color. That helps me see the contrast between your answers and what's going on. Okay, that is a quick tutorial on how to use Tinkercad. If you need more help, I'm going to make one more tutorial video for the next section, and you can definitely ask your classmates and partners to help you out.